All right, lesson 5. Interpret pump graphs. Critical task 101, 519, 3201. Introduction. Pump can be operated with a wide range of speed, operated with a compensate with the variation of the pump product with a specific gravity temperature of the pipeline topology. The speed at which the pump is operated with also determines the efficiency, therefore the cost operation to effectively direct with the pump operation. You must be able to balance the operation parameters of the pump that is accomplished by the use of the pump graphs. Part 8, feet of the head of the pounds per square inch. The pump graph is constructed to show the feet, the how flow, the rate of the gallons per minute with the barrels per hour. The pumps are equivalent to the gauge of the restriction register of the suction discharge pressure of the pounds per square inch. Therefore, the operator must be able to convert the pounds per square inch to feet and head to determine the flow rate efficiency for the pump. The equation of the converting with the pounds per square inch to feet is H times the pounds per square inch with specific gravity of at 2.31. 2.31 is a constant base for the column water for the 60 degrees Fahrenheit at 2.31 feet in height with the measuring 1 inch by 1 inch. 2.31 feet ahead of the water for the 60 degrees Fahrenheit equals 1 psi. 1 foot at the head equals 0.433 psi. 1 divided by the 2.31. Using the specific gravity, the different flows fuels the equation for the operator can remember the difference of the pounds per square inch. The fuel being pumped, the diesel fuel has specific gravity of 0.8254 with the pressure which was being pumped is 325 psi. Use the following equation as to calculate the feet of the head as 909. The head times 2.31325 times 325 is 0.8225. 4. The operator knows the pump that overcame with the 909 feet with the equation of the change the feet of the head to the pressure of the pump. P is equal to P times H is equal to specific gravity 2.31. The pumper operator must overcome the 909 feet head with while pumping the diesel fuel with a specific gravity 0.8245. It needs to be pressure which must be maintained using the equation P times PSI 909 8254 231 and 325. Part to be effective the pump station operation head of the capacity and flow rate. The normal head capacity of the pump station, the total head for the pump, the most efficient the operation for the design of the speed of the pumping unit, the repair. The RPM must be considered together with the required head and desired throughout the gallons per mile. Balance per hour. Establish minimum maximum efficiency design optimum standard military pipeline head capacity that contained with the field manual 542 military petroleum pipeline system provided with the table 1 maximum head capacity of the pump station as the total head against in which the pump is provided with the maximum pipeline capacity. Maximum head capacity are only used for the emergency operation or not used over the normal operation of the pump station. Should not be operated at a minimum capacity except for the emergency operation. Under the emergency condition should not exceed 24 consecutive hours. Part C, parallel series and installation electrical storage batteries are described in terms of the service series of parallel hookup in order to get 12 volts of electricity. The 6-volt batteries may be connected within the series. The same with the 2 6-volt batteries connected with the parallel provided with the 6 volts of electricity. But the current is double. The hydraulic system is very similar to an electrical system because the head capacity resembles the voltage flow rate. It resembles the current. 2 pumps connected with the series double the head capacity of the single pump, while the flow rate in gallons per minute or brake horsepower remains the same in 1 pump. The 2 pumps connected with the parallel double flow rate with a head capacity that remains the same as the 1 pump. Parallel operation not normally used with the petroleum pipeline pump station are constantly operated will require main pump. The objective of the pipeline design is to use the fuel pump station as possible. The size of the pump line maintains the required fuel. The pump station is designed to push the fuel products as far as down as possible. As a result of the pump situation are connected with the series. Part D, pump graph. Observe how the pump graph is constructed. The pump graph consists of the coordinated system in the uniform scale, which means the equal to the space between all the units of the graph is both the direction of the rate of the flow is plotted along the x and the horizontal axis, increased on the left to the right with the gallons per minute with on the bottom of the brake power horse on the top of the remaining variables are plotted against the y and vertical axis. The RPM's curve defines what is referred to as the operating speed of the pump. This shows the general gallons per minute with the dual barrels per hour by the total heated in the feet of the dual discharge and electrical efficiency percent. Public graph account. A common application of the public graph account is determined with the rate of flow efficient of the brake horsepower given with the total dynamic head of the feet of the operating speed of the engine, the RPM. Recall the definition: dynamic head for the height over which the pump should be pumped in a column of liquid. The rate of the flow is most commonly desired variable. The graph Number expressed in gallons per minute with the miles per hour. It has been engine speed of 1800 RPMs, total dynamic head of 160 for determining the flow. Rate of flow is gallon per minute, but the efficiency is the percentage of the brake horsepower. To solve the problem, to enter the y-axis at 160 feet ahead of the following line at the right of the intersect the head of the capacity of the curve at 1800 gallons per minute. At the point of all answers, determine the vertical up and down the head to read the rate of the flow of the gallons per minute. Drop down the y-axis. Read the answer at 850 gallons per minute. Determine the efficiency. Drop down to the efficiency curve. Read the percent of efficiency of the right-hand margin, 70%. Brake horsepower. Similarly, drop down to the brake horse curve of the gasoline. Read the answer. Answer the 300 brake horsepower. Note that the brake horsepower is expressed given a specific gravity fuel. For the design purpose, we use the 0.8524 specific gravity for diesel fuel. Part E, determination of pump speed. The individual pump station must regulate the pumps and keep the suction pressure of the next pump station down stream above the minimum normal suction pressure of the pump station at 20 psi at elevation less than 5,000 feet. When temperatures are between 100 degrees Fahrenheit, is equivalent to 64 feet of head of the mill gas. The minimum suction pressure of the pump station must be 5 psi because of the pump intricity, friction loss, possibility, vapor lock with the pump of the 5 psi is equivalent to 16 feet of the head of the mill gas. To determine the flow rate efficiency with the brake power in the pump station operation of the total pressure procedure. The discharge of the side of the pump station must determine the phase. Their pump is aligned with the connector of the series operation at 1800 RPM with the discharge pressure of 480 psi with the suction pressure of 220 psi with they are pumping with which has the specific gravity of 0.825 the 480 psi minus 20 psi 460 psi times H is 2.314 460 0.8254. In order to use the pump graph to divide 1,287 feet of the head for the three because the three pumps on line with the 429 feet ahead, locate the 429 feet ahead of the graph, refer to the right of the head of the curve at 1,800 RPMs, read the down to 600 gallons per minute at the flow rate, read the graph until the line intersects the brake horse curve at 1,800 brake horsepower curve and read the 680 brake horsepower. This represents one of the pump. 68 brake horsepower. That represents one of the pump. There are three on the line. Multiplying 3 gives the you of 204 brake power for the station. In the same manner, read of the efficiency curve. Read the 74% is shown. The graphics can be used at the pump station as well as the individual pumps. 800 gallon per minute with the pipeline line pump graph. The pump graph looks different with the construction interpreted the same as the other pump of the graph used the type of total dynamic head with the pounds per square inch feet of head of flow rate of water. Diesel fuel, specific gravity, mill gas, specific gravity from the 770 RPMs to 2100 RPMs. For example, the flow rate of 500 gallons per minute with the 1800 RPMs to pumping the diesel fuel with the pressure of feet of the can to determine to locate the 500 gallon per minute with a read up to 1800 RPMs. The curve the reading to the left, the given with the 1359 feet ahead at 500 psi. It shows another mainline pumping performance curve. Lesson 6. Schedule, evaluate, meter, verification. Lesson 6. Schedule, evaluate, meter, verification. Introduction. Account for the field. The one most important aspects of the operation of the field is using for the meters the accountability that you must understand how to work in order to properly protect the meter for the ensure the properly calibrated. Part A, type of the meter. Positive displacement meter, as the name implies, the positive displacement meter is the flow of the separating and flowing system and the voltmetric segment surrounding them. Typically, the basic sub-assembly to PD meter, external housing for pressure vessel, and inlet and outlet connections meters may be single double case construction. Single case active pressure valve on the outer wall of the measuring element. Small meter meters less than 6 inches are normally single case. The double case construction is used with the meters over 6 inches. The advantage of the double case construction is the piping and pressure is not transmitted in the measuring elements. Internal measuring element measures the volumetric flow of the constantly separated with the flow stream and a discrete volumetric segment and continuing them, and also to drive the counter drive train, the counter or totalizer the gear ratio of the drive train designed to the converted to fix the volume per revolution to the number of the gallons of the barrel transmitted into the counter. The calibrator is adjusted to counter the spillage through the meter. They may use to meter the outside the authorized tolerance because of the design of the the power displacement meter. It must be protected from dirt and trash. Any solid materials passing through the meter will cause the malfunction. The meter will also register any passing through the housing. The clearance between the housing and the van is usually 0.04 ten thousandths of an inch to 5,000 ten thousandths of an inch. Because of the simplicity of 4 thousandths of an inch to 5,000 an inch. The simplicity positive displacement meters are most commonly used in the petroleum operation, or use the master meters in place of provers. Turbine meters are precise and measuring devices, even though that they are classified inferred rate meters. They go simply to the measure of the device and complex instrument. They are measured much more smaller than positive displacement meters. There are three basic sub-assemblies: conventional turbine meter housing assembly constructed with a flange pipe spool and housing and internal parts. Internal parts are height of the internal subassembly, rotary blades suspended by the flowing of the stream, platform bearing in the rotor shaft, detector subassembly, and more of the complicated meters. You have the viscosity, the compensator, magnetic reed switch, and this kind of the meter is corrected with a 60 degrees Fahrenheit. When meter is installed, it must have the straightening of the vanes and upstraight and downstream of the meter. The pipe is usually 5 pipe diameters long, the downstream the 10 pipe diameters upstream that prevents the fluid swirl cavitation due to the back pressure, which will cause the thermometer to lose the accuracy of the meter, or the accurate with 1/10 of the 1%. Usually the custody transfer. However, the meter requires the maintenance of the expertise. They are generally not used by the military. Turbine meters, like positive displacement meters, will register any obstruction for the trash which can affect the flow. The meter must be protected while the operation. Protective devices consist of air eliminators and basket type strainers. Inferential rate meters. Inferential meters, instrument barometric element orifice plate. When placed in the flowing of the streams, it interferes with the flow of the rate, known as the physical loss of the pressure drop down. Viscosity of the fuel of the orifice plate of the machine with the exact tolerance. Second element is used to record the quantity of the fuel passing through the meter. It consists of piping high and low pressure sealing pots of the 24-hour record chart and 24-hour chart register the viscosity of the fuel with the base of the pressure drop of the flow rate barrels of the 24-hour period. When the metering is installed, it must have the straightening vanes upstream and downstream. The length of the pipe depends on the size of the type of the valve. The meter also requires protection of the trash and flowing stream. Line strain of the meter itself goes into a great deal with the maintenance expertise and the keeping the property operating with the condition. The orifice meters are used in the pipeline while in the interface of the passage needed to be monitored. Part B in the meter installation, protective devices, meter installation. Typical meter installation would be as follow the direction of flow, the filter separator, strainer, air eliminator, meter, and the strain is downstream with the filter separator in case the ruptured element strain will catch any fiberglass and filter paper that might get in the meter to cause it to hang up. There is also a strainer inside some of the suction side of the pump that provides with the prevent any of the trash entering the filter separator. Line strainers consist of the metal housing that holds the canister shaped wire strainer. The mesh is usually 25 mesh or more. The usual line of the stress is usually suction inside of the pump on the line side, in that side of the meter. The debris entering the pump of the damaging impeller meter. The maintenance and line strainer should be inspected. Cleaning on the periodic basis is recommended at once a week. The gasket are checked for the damage and cleaned and returned to use. The air eliminators are placed in the line of the intake of the side of the meter. It consists of the cylinder, usually 14 inches to 20 inches diameter, containing the baffle that is designed to force the flow. Fuel at the bottom of the cylinder to force the air to the top. On the top of the cylinder's diaphragm flow activated with the valve. Float valve with the handle opening, allowing the air vapor to escape the atmosphere. When in air, all air is removed. The float vapor rises to the product of the close of the valve. The planned gasket should be checked daily for the leaks, and the diaphragm should be checked daily to ensure the working properly to be replaced if needed. Remove any of the rust or paint. Part C, proving tanks. There are several types of provers available for proving tanks. The primary tank, the piping of the known with the volume when filled with the known volume compared with the meter of the unknown. Prover tanks normally range from the size of 600-gallon capacity. 5-gallon prover. 5-gallon prover is used for providing small meters of the tank trucks and in service of the station inspector type apply. With a mechanical display prover, these provers are then calibrated continuous loop and spheroid sphere displays the known volume of the known with one sensor of the known with the two sensors of the amount that displays the compared meter reading. You will find this the kind of meter of the fixed installation. They may be trailer mounted. One volumetric power prover, one opener of the big train are mounted in the fixed installation. They consist of the tank of the neck of the prover and the splash dome overlapping in the side of the glass is the glass. Aged glass of the next prover with the thermometer at the top of the bottom proving that is used in the installation. Where you have collaborator meter in the pipelines, loading of the docking, dispensing area, the maintenance of the meters is very limited. Check of the tension and distortion, make the side of the gauges are in good working order, make sure the thermometer is certified. Part D, verification requirements. Measurement will be verified based on the following factors: size of the meter, the total gallons of 110 to 99, 2,000 gallons, 200,000 gallons, 100 to 299, 800,000 gallons, 300 to 59, 599, 100, 200, 100, 200, 1.2 million, 600 and over 2 million meters will be calibrated at least every 12 months whenever the meter is suspected. Whichever comes first, the meter must be within 25 to 10,000 of an inch or 1/4 of a gallon for every 100 gallons. Registered the master meter. The meter is in tolerance more than 1/4 gallon. This must be adjusted if the taking out of services can be done, but it may be the meter factor, the meter percent error. To adjust the meter registered on the gallons pump. The instruction for the adjusting meter are normally placed inside the top of the cover in the manufacturer's manual. Preparation meters must be checked under the normal operating pressure flow rate. The prover to have the capacity for the no less for the volume delivered through the meter in 1 minute. The fill the prover and then empty out the zero. The mark of the dry run. The prover the air pockets and the line warms up at the meter. The dry during the dry run. The time and the flow rate can be determined. All gauges of the thermometers will be checked for the accuracy, and all fitting of the valves may be checked for the leaks. Verification record of the report meter test result. The following information will need to be included on the meter verification reports and records in order to obtain a reliable meter performance rating. Closing meter reading after the prover is full. Opening the meter reading if this is for the meters that cannot be set to zero. Registration quantity recorded meter. Example: closing meter reading is 2,762. Opening meter reading 1,920. Quantity record 2,760 minus 1,920 is 842 gallons. Temperature meter stream temperature correction factor. The temporary temperature correction factor registration of corrected with the 60 degrees Fahrenheit equals the amount of the pump time at the correction factor. Emphasize the time, and the second usually time takes less than a minute to fill the prover. Lamp's time to the test and put to minutes. The flowing rate is the gallon per minute with the second. It must be corrected with the minutes. The rate of flow. The total register reading the corrected 600 gallon 60 degrees Fahrenheit divided in the lapse time of the test equipment equals the rate of flow. This will tell whether the meter is running at the prescribed flow and the rate 1 minute. Closer prover tank, the rate percent of the proving is allowed to be excess in the rated capacity 1% or 1% the graduations are in tenths per thousandths. The prover is rated at 840 gallons. The closing and then plus 2%. This must change the percent to decimal. For example, if 2% is changed to 0 to 10 thousandths, the multiple prover capacity is 840 by 10 thousandths equals 168,000 gallons. Note that you must pump 841.68 gallons. Closing the prover tank, the readings at 841.68 gallons. Opening the prover tank reading is always 0. Delivering the close of the proving tank reading, the minus opening reading equals delivered amount. Proving temperature. If the prover is upper and lower, the thermometer uses to be average of the two. Delivery correction to the 60 degrees Fahrenheit meter. The factor equals the property of the quantity of 60 degrees Fahrenheit divided by the meter. Quantity of 60 degrees Fahrenheit divided by the meter. The quantity of 60 degrees Fahrenheit. The factor carried out to the 4 decimal places. The meter certification record of the meter certification record in conjunction with the meter test results. Your proof of the meter has been properly calibrated. The following items will include the meter certification required to ensure that the meter has been properly tested and calibrated when required. Date of the meter was verified. Meter the factor. What meter factor was in 1/4 of a gallon. Vertical verification adjustment. Not required, not performed, date, not required, performed, date required, but not performed. If adjustment is required but not performed, the meter factor should be used adjusting all issues and receipts through the meter. Use the meter verification record, remarks, and any repairs and adjustment the meter should be recorded. Lesson 7, pressure testing pipe hose line. Periodically, due to the corrosion, erosion, and leaks, the cracks occurs and must be corrected immediately after they happen. This lesson will explain provided procedures even involved. Part corrosion. Corrosion of the process of refined metal returning to the natural form, which happens during corrosion. Similar chemical action to take place on the battery. Negative charged atomic particles and like all the electrons give it a medical called the anode. The particles from an electrical current through the pass through the electrical conductor called an electrolyte. The electrons are attracted to another medical called the cathode. The circuit complete with the current returns to the anode with a metal connection. During the process, the metal acting on the anode breaks down and deteriorates. The metal acting as the cathode protected with the suffering no damage. Different same metals corrosion can involve the two different metals that also can occur when an anode and cathode are the same metal. For example, the newly casted metal will act as an anode to the older similar metal. Medical and acidic surroundings will act as an anode to same metal as less than acidic surroundings. The metal in air lacking oxygen will act as an anode of the same metal in oxygen-rich atmosphere. Cause of the pipeline corrosion. The corrosion take place that must be an anode, cathode, electrolyte, and some of the medical connection between the anode and cathode corrosion can occur with the pipeline under the following conditions. Different metals come into contact with the curves of the section of the pipeline joined with the couplings, fitting the valves that use the moisture, chemicals, and surrounding ground and the air. Acts as an electrolyte. The pipeline provides necessary metallic connection between the anode and cathode. A new section or pipeline is put in place of the old one. The new pipe acts as an anode to the neighboring old pipe. The pipeline passes through different kinds of soil. Electrons will move the pipe of the sections laid on the acidic section soil, low acid soil for the pipeline section, high alkaline area section, low alkaline area. The swamp is an example. The acidic area, the ground made with the moist clay and alkaline. The pipeline must from underground to above ground, must give it underwater to above water. The pipeline passes the fine soil, but the fine soil holds water dissolved minerals acts as a better electrolyte with the course of the sand and earth. Stray electrical currents from the outside power source of the flow of the pipeline that carried along with the leaf of the pipeline re-enter the soil of the area of the pipeline where a stray current enters, then acts as the cathode area with leaves, then acts as an anode. An example of the possible source of the stray currents is ground wire with electrical devices such as electrical power pump. Preventing an internal corrosion of pipeline can be corroded with the inside well as the outside of the internal corrosion with the accumulation of the moisture, water, milk, scale in pipeline friction. Pipeline caused with the rapid movement of the fuel produced with the heat and speed. Corrosion process. Internal corrosion can be cut down in two-way scrapers. One way with the run and scraper with the pipeline to prevent material from building up in the line. Corrosion inhibitors are the method of using the corrosion inhibitors. Corrosion inhibitors are chemically added with the fuel to prevent the formation of result inside the pipelines and storage tanks. Prevent external corrosion. Several techniques to prevent external corrosion. None is perfect. The combination of several methods is used to cut down with the corrosion of the most possible. Design corrosion control is considered before the pipeline and the built. Soil studies are made with the planners, and the planners to avoid high acidic areas and swamps and the high alkaline area of the clay deposits. Protective coverings. The pipe sections are coated with the factory construction site of the coal tar and enamel. The protective wrappings are put around with the pipeline before it is buried. The enamel wrappings are waterproof. The barrier between the pipeline surrounding the ground and the atmosphere. They prevent the current of leaving the pipeline. A pipeline is repaired with the more important protective covering being restored to the original condition. Sacrificial anodes. Another way to protect the pipeline is sacrificial anodes of the type of the sacrificial anode. The magnesium, the bars of the magnesium burned with the ground bed, but located away with the pipeline, with the anodes connected with the pipeline, insulated with the copper wires, and this way the pipeline becomes the cathode. Magnesium anode with the sacrifice to protect the pipeline corrosion and not stop. It's only directed less important. Surface mitigation bonds. Mitigation bonds protect the pipeline from the stray electrical current. The bonds are then insulated with the ground cable to serve it as pass for the less resistant to stray electronic currents. Stray currents will tend to flow through these cables instead of the pipeline. Part B, pipeline testing. A new coupled welding pipe should be tested before accepted to surface. Using the organization test is done to locate the leaks of the blocks and lines of the flaws in construction. Testing may be done with water, fuel, and compressed air. Water, the testing is safe for the testing the fuel. There is disadvantage of using water. Water may be scarce in some areas and it may not be possible to pack the line with water. The water expands as it freezes. It should not be used to test a line that is in any chance of the temperature falling low enough to freeze in the line. Water should be removed to place early from the line before it is packed with fuel, and in combat situation the process could use the valuable time. Fuel is in any position with the testing of the water. Testing is usually done with fuel. Several conditions should be met with the fuel is used. The test section should only be on the outside of the city, a heavily populated area. Each building within 300 feet of the testing section should be empty of people. The test section should be watched. The patrol during the test. The people running the test should be in constant contact with the patrol. Fuel should be low grade with the non-critical fuel that does not vaporize quickly. Compressed air. If the test section is in the area, many of the people, the line should be tested with the compressed air. The compressed air should be used for the test of the section of the line of the crossover Compressed air can only be used to clean the vapor-free. The do not compressed air testing the high-pressure overland pipeline. The test can couple the welding pipe with the compressed air. Divide the pipelines into smaller sections of those using the testing of the fuel water the size of the pipeline air compressor before deciding how long the suction should be tested. Do not try to test more than 5 miles at a time. Use the gate valves placed 1 mile apart for the pipeline to break the test section into 1 mile pieces. The pipeline must be tested quickly. Test the line mile by mile instead of 5 mile sections. Break the line at each for the gate valve. Uncouple and move the air compressor forward for each test. The method cuts the time into and takes to empty a line of air, uncoupling, beginning the test section of the rest of the pipeline. The cap off to the section coupling made with the blank end to make the coupling at the cut of the hole, the blank of the end, weld the air hose coupling in the blank of the end over the hole. Attach the air line from the air compressor to the blank end. Close the gate valve at the end of the first mile of the test. Pressurize the line of 90 pounds per square inch to the gate valve. Patrol line, swab the couplings while soap in the water with the look of the bubbles caused by the air escaping. A leak is also listed in hissing sound and escaping air. If the leak must be repaired, close the gate valve at the end of the next mile of the test section. Open the gate valve at the end of the first mile. Relieve pressure repair with the leak. Goes the gate valve at the end of the first mile. Pressure with the first mile. Pipeline patrol again. Listen leaks. If the first mile checks out all right, close the gate valve at the end of the second mile of the test section. Open the gate valve at the end of the first mile. Pressure of the first mile. 2 miles of pipeline. Patrol for the leaks of the second mile. If the leaks of the close the gate of the valve at the end of the first mile of the pipeline to prevent loss of the air, or to open the gate of the valve at the end of the second mile to relieve the pressure on sections either be repaired with the repair leaks. If they close the gate valve at the end of the second mile, open the gate valve at the end of the first mile. Pressurize the first 2 miles of the pipeline. Patrol again to look at the loosened leaks. Repeat above the steps until the 5-mile section of the pipeline has been tested. All leaks. Repair the pressure of the whole 5-mile section for the 24-hour towers if there's enough time. Anchor on the end of the pipeline and after the test is over and hold over the down heavy equipment so that it cannot be wiped around well. And everyone in the area stand clear of the line. They empty it from the air line by opening the gate valve at the end of the test section. Open the gate valve as quickly as possible. Preparations for testing. Before testing begins, several actions should be taken to ensure the test runs smoothly. Test all the radar telephones for accuracy of all the gauges. Make sure enough repair clamps are on hand. Make a firefighting equipment. Make sure tank vehicles, drums are nearby in case of the section that has been to be drained. Either shovel material to dig a line with the pipe as the test site is case if there's a spill. The pipeline should be divided into test sections. The usual test length is the distance between the pump station. About 15 miles short distance can be tested using a gate valve to divide pipelines into smaller segments. During the test, line pressure of the welded pipelines measured with the gauge of the pump station as the line taps between the pump station before the test has begun over the coupling leak gaps. The pressure gauge is mounted with the coupling pipelines. If it's measure line pressure of the clamp are mounted every 1/3 mile, particularly if they are not used less every mile. They mount over coupling leak of the pressure test, removing the vent plug, put up a pressure gauge of the vent plug hole, loosen a split ring coupling of the pipeline, remove the gasket, and push the nail under the gasket to make a small bit leak, and the nail should be not damaged to the gasket. Not go the way over the coupling leak with the remove the nuts, but over coupling the leak clamp, the two half of the leak clamp, the 2-part gaskets over and around the split ring coupling, but the large slide bolts backing on each side of the clamp of the tighten smaller packaging bolts are in housing leaking the clamp the seal between the gaskets and the pipe. Part C, pipeline patrolling. When in the surface of the pipeline, patrol with the last 2 people to parts of patrol look for the leaks and the signs of the leaks, such as an oil slick on the stream and or dead with wilted plant life nearby. The report on the DA form 5464 petroleum product pipeline leakage report. Patrols are to prevent heat and sabotage theft. They are sent on often at different times each of the time, so that no one predicted the patrol may be in a specific area. Usually, patrols are not sent out during the night because the leaks are hard to spot when the flashlight's being used. Patrols can be made on foot by using Jeep or truck or using a small airplane or helicopter. Or motor patrols equipped with radios, telephones, coupling wrenches, gaskets, repair clamps, and minor spot repairs. Minor patrols. Motor patrols can carry more equipment and cover more territory than foot patrols, but they are limited to areas where pipelines run along the side of the road. Foot motor patrols report major leaks to the pump operator as soon as possible. Air patrols, when used, need to check out the pipeline quickly, and they use the area of the foot and motor patrols are difficult or impossible to use because of the rough terrain. Especially true of the mountainous area. The air patrols require fewer persons to patrol more pipeline than do the foot and motor patrols. However, the air patrols will be limited to because of the bad weather. Air patrols report all problems by radio so the repairs can be sent to work on the pump line. Lesson 8, Disposition and Interface. Disposition interface. Introduction. Petroleum supervisor, you must be able to determine whether the thousands of barrels projected in the pipeline system at any time, and in order to do this, provide efficiency distribution and use of the units, you must be able to schedule a pipeline to keep accurate records. Product received and issues based and intermediate with the head terminals. Part A, duties. The Chief Dispatcher, usually Petroleum Distribution Office, the Petroleum Pipeline Terminal Operational Battalion, Petroleum Group, the Chief of the Operation Control over the whole pipeline system as the rule of the Chief Officer normally located at the headquarters responsible for the control of the pipeline. Some of his duties are coordinate with the development monthly and his daily schedule, relay pump orders to the district dispatcher, keep records based on hourly reports, pump station, tank farm, disposition stations, other installations, keep record of fuel received, fuel delivered, fuel left in the system, fuel lost, report daily information to higher headquarters. Shift dispatcher responsible for the control of the pipeline in the name of the chief dispatcher during the working shift. The district dispatcher exercises control over the pipeline in the district according with the instruction of the chief dispatcher of the petroleum operating companies which have the dispatcher normally an OAIC petroleum control section, product control section controlling the 60-mile section of the pipeline dispatch, transmit hourly pumping the delivery rate. Reports of the chief dispatcher. The reports include barrels pumped the received corrected with the 60 degrees Fahrenheit suction discharge pressure at a pump station, RPMs at which the pumps are running, batch changes, rate of flow in case of emergency. The dispatcher assumes complete control in the pipeline, included the diversion upstream pumping the empty tank of the shutting down the line, halting the pump infected with air, pumping from the intermediate tankage when required, inform the chief dispatcher of the pump and actions taken. Part B, analyze consumption of the graph. The dispatcher should maintain the consumption graph of each of the product stores with some of the graphs valuable visualizing, presenting in the future. Stack on hand storage position. The graph is set up for the total barrels, product storage air available to each terminal, not an individual track. Tanks. Allowance of vapor to space calculated with 5%. The total storage capacity safety level will normally be based on the 4 days of the same supply average display consumption. This may vary on compliance. Command and guidance calculated issue received with the showing the start of one past 0-100 hours one day, past 0-100 hours the next. The starting balance of Mike barrels was 1 past 0-100 hours. Projected tank cleaning will also be shown. The consumption graph and the capacity will be plotted against vertical axis time of the horizontal with the vapor space shown on the top of the graph. Safety level at the bottom of the graph. Storage tank cleaning will be shown at the top of the graph, deducted with the total capacity issued, and the receipt will be shown over the 24-hour period. Part C, analyze the monthly pipeline schedule. The monthly pipeline schedule should be programmed with the movement of the pipeline, which is known as the product is required for the 30-day period. The schedule can be prepared to determine how long it will take the product to reach the destination after the product has started with the pipeline. The schedule is merely a graph that shows line capacity and barrels distance plotted with against time hours. The preparation includes before the graph is made. No of the hour lines is to be pumped. Each of the day must be determined. The time should be shown at the beginning and end of the given working day. The time chart is drawn with the vertical axis to the line fill. Horizontal axis is drawn to shorten the time period. Terminals are located at the chart with their respective line fill distance and downstream with the base terminal. The terminals are plotted vertically. Each bag is labeled in product batch number. Each of the product is marked on the graph with a different color. The distance of the barrels dividing the pump rate equal to the number of the hours it will take the given the batch to reach the designated place. The slope throughout the line stays when there is no intermediate stripping. When the pump rate stays in the same stripping is when all the part of one or more of the batches is taken off the pipeline at the intermediate terminal. When the product are taken into a terminal on half on the pipeline and is shut down, plotted in the monthly pipeline schedule. A dotted line on the horizontal time axis shows the time to prevent shut down. The second vertical dotted line shows the pipeline goes back on the stream, and it should be noted of the schedule that is static condition stripping with the terminal shown in the same manner as the static condition horizontal vertical dotted lines noted with the block form dotted lines that their stripping action is taken into place. Vertical lines represent terminal station points at which the sloping line intersect the vertical lines and show scheduled arrive times when all throughput lines have been drawn. The graph represents all scheduled pumping and daily delivery operation for the month. Part D, analyze and daily pumping schedule. The schedule is used the preparation prepare for the pumping intervals abbreviated tabular from the form of the monthly schedule. Each day concerned with the schedule show change in emergency need is usually prepared a week in advance so that the dispatching section can have a week's supply. The dispatching section uses daily pumping schedule preparing the graphic progress of the daily pumping order. Party analyzing graphic progress chart. The graph progress chart provides with means of visualizing position batches and their progress throughout the pipeline and prepared one day in advance, indicated with expected to take place in construction primarily same for the monthly schedule, except that it is 24-hour period preparation. Include hours as shown on the vertical axis standing at the midpoint on the graph, counting on the number of the hours of the pumping of the day. Line fill the terminals, pumping stations shown on the horizontal axis. Line fills and show the midpoint zero barrels base terminal moving the right intermediate terminal batch scheduled and enter the pipelines are plotted with on the left of the base terminal zero barrel line. Plot the number of barrels scheduled to enter the pipeline at the base. Draw the horizontal line left to equal to the name of the draw the horizontal equal to the normal barrel scheduled to enter the line. Draw broken on the sloping line back to the base terminal timeline. For example, the point where the broken line crosses the base terminal timeline should show the time of the new product be started with the solid sloping and the extent with the right of the base terminal time and the same with the rate of flow. The degree of the slope that shows the pumping and the rate of throughout the pump line and the terminal is told. The product of the pipeline slope throughout the output must be changed with the stripping action as shown with the broken vertical line. Any shutdown of this line should be shown with the broken horizontal of the solid sloping line will be plotted with the vertical and duration of the shutdown. When batches are moving ahead behind the schedule, the dispatcher can either adjust the chart or adjust the flow rate. The points are in the sloping rate. Lines intersect the vertical line. The terminal and stations should be scheduled arrival times. Part F, batching procedures. Batching sequences with two or more products are to be pumped in the introduction of the pipeline and sequence for the result and least information and interfacial material. In addition to creating the usable interface, the batching sequence also aids the quality and quantity control. Products likely to be batched in military multiple product pipeline include mogas, diesel, kerosene, jet fuel. Exact batching shown procedures are not fixed. However, batches should be arranged to protect critical products to produce interface that can be used. Batching designation. A batching number. The batching designation is a number has three parts. The first part consists of the product code number, the code number, the sequence of the fuel is going to pipeline. Second part is the batch number. The number tells you how many batches of each of the product have been pumped since the first of the official year. The third part is the amount of the mic barrels per batch. 21520 is JP 1415 batch for official year. The amount of the batch is 20,000 barrels. Detection of batch change and control of the product flow through the pipeline. It must be determined where one batch ends and another batch begins. The following method are used to detect the batch changes in the pipeline: gravity, distance, color change, liquid buffers, MOGAS neutral product, physical buffers, scrapers, rubber balls, and dye plug colors. Direct personnel verify arrival time by the sampling the terminal operator's office. The dispatcher set the time and the frequency observation before during the batch change. The suggested procedures begin taking readings 20 minutes before the expected arrival time of the interface at 5-minute intervals. 5 minutes prior to the arrival time reading of the first interval when the arrives. Samples are taken intervals are from 1 minute or less. Sample lines may be left open or flowing to ensure the representative samples during the actual change. Problems caused pumping more than one product through the pipeline involves mixing of the product and disposing of the mixed portions. Progressive of the different product of the interface must be followed so that the products can be taken off the line at the right place. The volume interface depends on the difference of gradivity, viscosity of the adjacent products, and the pressure, velocity of the steam stream. It also depends on the interior condition of the pipe, the number of the pump station, the distance traveled by the interface, the difference of the gravity, the viscosity, and will also affect the interface disposal. Interface size can be reduced, maintained by a pumping rate needed to keep the heaviest product in line with the turbulent flow, and the size can be reduced by putting products in the line by proper batching sequence and by keeping them in line. Determine the interface cut position. Cut points made in the interface between the two products of the pipeline are controlled as follows. A head cut, a midpoint gravity, and a tail and a heart cut. A head cut is made at the front end of the interface at the first gravity change. Midpoint is made at the middle of the interface. Tail cut is made at the last gravity change before the pure products. Heart cut is known as the narrow range and usually taken in the middle portion of the stock being distilled and treated delivery and pour product was taken for the middle batch of the sum of the immediate point of the pipeline. A portion of pour product was taken from the line before the after and interface the intermediate terminals. Disposition interfacial mixture. The disposition interface is determined by the product use. The limits off specification. Products with the quality default with the established use limits may be used for their intended purpose. The extent with which the product can be safely thrown off the specification determines how much of the adjacent product will be blended with it, and the alternatives for the disposing interface. These alternatives depend on the type of the batch. There are also pictures, the picture of the cut in one or other adjacent product that protects the critical product that creates a usable interface. Dispatcher should be determined percentage of each of the product and the interface is to be cut into the adjacent products. Make sure it's divided between the two adjacent products, usually with the mid-gravity. The point with the provided minimum containment for both of the products blending tolerances are considered. Dispatcher personnel should be determined the percentage for each of the product interface to be cut in adjacent products. The whole interface is taken off the line and slope of the slab tank of the ladder is bended in the incoming of the product with a mixture. Made comes new product with his own identifying. The dispatch personnel should determine the percentage of the product and slope tanks that are to be using in blending. And that completes the direct pipeline operations, subcourse 5096. I hope you enjoy this.